Cool. So if you worked with legacy code, then you know it's somewhat like dealing with the force, right? You have all kinds of emotions, right? Fear, anger, hate, suffering, right? Yoda says it best, right? But I'm here to say that, yes, dealing with legacy code can be painful, but with open source software, there are ways where it can help you. Something about me, my name is Indu Alagarsamy. I'm a developer. I work with particular software, the makers of NServiceBus. And I worked writing software for the past 15 years. I took a cap at 15 plus years because I don't have my Fox-based experience. Fox Pro screen builder. Remember that stuff? Yeah. And so through the course of years, I worked with different legacy systems. I have to say VB6 was my most painful experience, dealing with VB6 in today's world. But it's a different mix, right? Legacy doesn't mean like legacy of 30 years ago, although that is reality in some cases. But legacy could be something that you're new to, where the company has dealt with the software. So 5 years into the software, you're a new developer, but the stuff that's there has been around for a while, right? So I just want to share some of my experiences of how I've dealt with legacy code and some of the patterns that I've applied that have helped me. So it never was like too huge to begin with, right? Everything was a small thing that started. So a business probably has an idea to try. They think that it can make money. And a few developers get together and say, hey, how can we solve this problem, right? So something, and it's really, really simple, right? Small code base, front end, back end, stuffing some data in the database, and it's done. And the deployment isn't that big of a deal, right? Probably at that time, everything probably fits in one solution. Build it, and it builds, Xcopy it, throw it on a server, it's deployed. And again, maintaining it isn't a big deal. Stop the service, restart the service, what could be so bad, right? So once the business tries the idea, it could probably take off. This is an idea that probably is very valuable. And a lot of people try to buy into this idea, and it starts getting bigger, right? It evolves, right? And you've got different features now, and they've hired more developers, more features. The company is probably grown, and now you've got services talking to other services, a whole bunch of things, and they're all stuffing data into the same, probably, database, right? So, and then it gets even worse, right? You, end up with this nice big ball of mud, mess, whatever you want to call it, right? Where now this is at a stage where things are no longer simple, and it doesn't get like this in one day. It's a slow, organic process. Things got added slowly over time, right? So it's in this state, and this is the state where people are starting to feel the pain, right? It's not just the developers that are feeling the pain. QA is feeling the pain too, because if you change something and you deploy it, and it ends up breaking some other part of the code that you had no idea, then they're going to be, at your throats, like, hey, you broke this stuff, right? And it's not just QA, it's the ops people, right? So you can't just deploy this like, hey, I'm going to do this right now. You probably can't. You probably have to schedule some proper time with the ops guys to stage this deployment, find a proper time where you can take down services where it doesn't impact business, right? So there's a whole bunch of stuff going on. And this is kind of probably where you come in, right? 5 years later into the picture where there's an existing code base, legacy. And it is legacy for a reason, right? This is the company's flagship product. This is the one that's making money, this is the one that has to work. And they're hiring you because they're at the stage where this thing can't scale anymore. And there's a whole bunch of pain associated with all these different departments. And now they're trying to get it, of course, business wants to always make more money, right? That's the whole point. That's what's getting us getting hired, getting us getting paid. So if the whole point is money, it's like they're asking us, hey, what's stopping us, right? Do you guys need more hardware? Like, what's the problem here? Why can't, this get better? So you come in, you've got a fantastic resume, the whole stack of technology, company likes you, and they look at you as a potential person that can actually come in and solve this problem, right? Of course, you're the Jedi, right? You can be the Jedi, but who said Jedis can't feel the pain, right? We're human beings too. So there's a whole bunch of pain in different areas, right? First is like setting up your development box. I mean, how can that be hard? I worked in an environment where like it was dealing with hardware aspects and software aspects where you couldn't just get it up and running. It's not as simple as let me pull down the source from GitHub and I have filing and running. It's not like that. I mean, you have so many dependencies where it takes you a few days where you're at a point where you can set a breakpoint to debug that code, right? Sometimes you have to like, I've done this before and I hated it, which is like writing logs and making some code changes in my development machine in one corner, writing a whole bunch of logs, and then taking that USB stick, taking it to the lab, sticking it in, executing it, collecting the logs, coming back to my machine. Let me see what's going on, right? I mean, it works, but there are ways of doing it better, right? So then there's the actual complexities themselves. So if you're trying to introduce this new feature that business wants, right, you have to wade through this code. And this was a .NET app. It was an old code. And we were warned, like, tread very carefully, because it's a 2,000-line function, and that's like the important part of the process, and you better not be breaking stuff there. So when other developers on the team tell you this, it's like, oh man, I really don't want to touch that code, right? So there's this complexity in trying to like figure out like where can you actually introduce this change. Of course, finding it out is the hard part, trying to understand the dependencies and stuff, right? But actually going in there, making the change, and making sure it works, and making sure you don't break other stuff in that process is also complicated. And sometimes build time is a factor. In some environments, just building can take like a few minutes, and minutes can be like really long minutes. It's all, time is relative, right? And again, all this stuff, in the cases I've seen, they all share the same database. And so what's the pain in shared databases, right? You've got all these different services, and they all operate on that same data. And as new features like are put on top, or bolted on top and top and top, they are all talking to the same database. There could be one service that looks at the same piece of data, does a bunch of processing, fixes some state, and says like, okay, this is the new state. Then there's another service that's polling the database, the same table, picking up like, hey, give me all the rows that match this criteria because that's the stuff that I need to process. And then it does its own thing and puts its state for which another service polls, right? And pretty soon, in this type of situation, you're going to have like locks, lock escalations from row locks to page locks, table locks. And the DBA is not going to be your best friend. And we've had like 2 DBAs, not one, because the amount of data was so massive that the company had two database administrators. And the one thing they hated the most was like the amount of applications, different applications, running timers, hitting the same table. And that's not something that they enjoyed, because they're the ones that had to come up with like query execution plans to make sure that this thing doesn't, you know, fall flat. This thing had to be up and running because this was serving their customers. So there was a lot of pain for the database administrators as well in this sort of model. And the other thing is temporal coupling. Like code, when it gets, you know, services calling one another and it gets temporal, I mean, it's coupled. So one thing was when we were at this sort of state where, you know, things were kind of in this mess where we wanted to scale, but we didn't know how. The VP brought in this cool dude from Microsoft. And you know he's important when he arrives in a chauffeured vehicle, right? So he spent a whole day looking at the code, trying to look at the various applications, try to give us tips on what could be better, how it could scale. And one of the things that he pointed out was like, hey, your services, like these two services, they're coupled temporally. And back in the day, that was like the first time I'd heard of the word temporal coupling. I mean, he had a nice explanation, but it didn't quite like get into my head at that time because that's the first time I'd heard of it. And then, so temporal coupling is like, you know, when you have service A and service B, and A can't do its job if B isn't around. So if A calls B and B isn't there to answer back and say, hey, here you go, A can't do its job. So that's temporal coupling in a nutshell. But it didn't really get into my head until like I went to Starbucks. My day, even today, starts with Starbucks. I used to be a big coffee addict. I used to get double espresso every day, like that's the first thing. So I walk into the line, I order my drink, right? And I was thinking, like, if Starbucks, you know, if I was writing services, like, you know, like what happened in Starbucks, like, you know, if I wrote them the way I did then, how would it be? It would be something like this. You have the cashier and the barista, right? And, oops, the cashier and the barista. Somebody orders a drink, right? Here's my super complicated double espresso upside down macchiato, upside down because there's a way in which you add the caramel which makes the drink taste better. Sorry. My OCD, right? So you order the drink, and then in the software sense, this cashier service would call the barista service and say, hey, here's all this complicated details in this order, blah, 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 right? So you make up that request, right? And say, here you go. And you wait and wait and wait until the barista gets back. It's like, here's your drink, right? And then the cashier is like, hey, yay, I got the drink. Now let me go with my next thing that I'm supposed to do, which is actually process the cart, right? And then, like, here you go, I return the drink object. If Starbucks were to operate that way, they'd be pretty much out of business, right? Real world doesn't operate this way, right? So real world is autonomous. Real world is full of asynchrony, right? I mean, if you go into Starbucks, I'm just standing in line, I just order my drink, the cashier takes my card, charges my card. I haven't gotten my drink yet. I mean, there is no up to the millisecond consistency, right? I can't stand there and say, I paid and give me my drink right now, right? It doesn't work like that. I am going to get my drink, I paid, I wait. And the cashier takes down all that notes of what my super uber complicated drink was, and sets it aside on the table for the barista. The table is actually the queue. And you can think about the cup as a message to the barista. And that's it. From that point, the cashier is done. The cashier can move to the next customer, start fulfilling more orders, right? In the meanwhile, you could have a table full of these drinks queuing up, right? So real world doesn't operate very synchronously. And that's where event-driven architecture can help. And so event-driven architecture kind of mimics like what's going on in real life. It's full of events, right? Like the cashier telling the barista, hey, I have a drink ready for you to make. That could be an event, right? The barista is not constantly asking the cashier, hey, do I need to make any more? Do I need to make any more, right? I mean, doesn't have to, right? The barista is like chilling out until the cashier puts that cup on his queue and says like, or her queue, says like, here's the drink you need to make. That's the trigger, that's the event, and that gets picked up and served, right? So real world is full of asynchrony, and doing that, you have this beautiful autonomy, right? You can have two different services that can live on its own without having that dependency on each other. And you could have barista changes, right? You could have, barista walk out, and no big deal, right? The drinks are right there on the queue. Pull in another barista. If the line gets too mad, have two baristas fulfill the order, right? You've got a whole bunch of flexibility in that model. So this event-driven architecture has been around for many, many years. There's one of my favorite books is the Enterprise Integration Patterns by Bobby W. and Gregory H. I'm not going to pronounce their last names. Sorry? Thank you. I'd like to pronounce it as Hope, but I wasn't sure, but thank you. So, that book is a fantastic book, and in that book I found more than 150 messaging patterns. This thing has been around, and one such pattern is the publish subscribe, where like if you now ditch the barista and the cashier and kind of delve into like a real sort of world with sales and customer relations and billing, sales can publish an event saying order accepted, right? And then do whatever it's doing. It doesn't need to worry about what billing is doing. It doesn't need to worry about what customer relations is doing. But this event can trigger other business processes. So the fact that an order is accepted, that event can drive, or customer relations or billing could be interested in that event. This is like the barista, like when a message gets in that queue, you serve that drink, right? So customer relations could go like, hey, there's a new order accepted. Now, should I make this guy, a preferred customer? That service could be, it's one thing that it needs to do, or it's doing is, it's trying to see who has spent the most money, right? So it's just watching for that one event. And when it has its own data that it maintains, like how much sales as a customer, has done in the past, and it's keeping track of that. So when that event arrives, that service can make that decision and say, hey, this customer is now preferred. I'm going to publish an event. Now, billing could look at that same event and perform a completely, entirely different task, right? And all these things are autonomous. They don't depend on each other. You have this very nice, loosely coupled system of services working together to solve your business problems. Now, great. How does OSS help, right? I think, okay, so this is again based on my experience. When I was at this exact stage where I was dealing with legacy and I was like looking at different architectures to kind of see like, what could help like my company at the time, was like, yay, EDA, but okay, next step, how do I implement this? And that's when we kind of looked at various different solutions at the time. And our VP proposed BizTalk, and it's like, whoa, okay. So, but he was great. He was fantastic. He was like, you know what, like, go ahead, research away, and come back with me and tell me, what's a good solution. And when I looked at open sources, and I looked at two different buses. Mass transit was one, and NServiceBus. And I looked at both, and at the time, NServiceBus offered a commercial support for customers that the company was more comfortable with. So they decided to go with NServiceBus. Now, of course, you could write your own bus, right? I mean, there was this, this book on WCF, which I used to consider the Bible, which is Inside WCF by Yuval Lowy. I mean, there's an appendix with 33 pages of like how you can implement your own publish subscribe system. Sure, you could start along that route and do something in a few days, but is that really your line of business, right? Is that really the problem you're solving? You've got a whole bunch of features to write and problems to solve. Is writing a communication framework one of them? Especially when you have a few that are existing and that have been battle tested, right? Have been around. So instead, use one of them. And the cool thing is you can contribute to one of them, right? So like as I started using NServiceBus, the one thing that I found was like the community forums was fantastic. I was a complete total newbie. I hadn't I wasn't even sure the questions I was asking was making sense, but someone from the community always chimed in and said like, hey, here's how you solve the problem. And I saw that and it was fantastic. It was like, developers from different parts of the world, like answering questions, helping you, finding you new ways to solve, pointing you in different areas of like how you could design your software, things that you've never thought about. That was kind of cool. And then I started, racing bugs, and that was the first time I created my GitHub profile to start contributing. And I raced bugs, and I thought what would be cool features, like I'm using this in this way, but I think it would be better if it were to do also this. So you're now, contributing to that framework. And now, by having that feature, it might help somebody else too. So you're now part of this bigger ecosystem, right? So yeah, like use something that's already there that makes your life easy. Now, when you're trying to use something, life becomes much simpler. Now, yeah, we want to use event-driven architecture. We have these existing .NET apps. We want to be able to send messages, publish events, subscribe. How do I do it, right? The how do I do it becomes very simple. You just go install a NuGet package, and then you have the bus. The bus is the thing that actually takes one message from one .NET app and delivers it to the other .NET app, right? So it's a NuGet package, and off you go. You have the bus, and you have to, of course, write a few lines of code that would add the bus to your application. But that becomes very simple. Instead of going and writing your own communication framework, which could have taken you days and days and days, now you're off and running with a library in your project, a few lines of code. And publishing an event, it's not a big deal. It's a bus.publish. And you're just publishing a simple DTO. And the message that you're publishing or the event that you're publishing is just a DTO. And it can be, a POCO, right? It's nothing else to it. And on the subscription side, if you're interested, let the bus know, hey, there's this event. I'm interested in the event. And once you tell the bus will take care of like subscribing and making sure that when the publisher publishes events, that event will get delivered to your application. Now, what happens when that event arrives? It's totally up to you. This is where you put your business logic, right? This is the part that you're trying to work with and be concerned of like what you need to do, right? So, and it's again like a very simple piece of code. Say like, hey, anytime a message arrives, just call my class. This is the function that needs to get invoked. So that's pretty much it. Now again, how does this tie with legacy, right? We started with legacy, this big giant ball of mud thing that was there, and that's the pain that we want to solve. And one way that you can use the event-driven architecture approach is by instrumenting this thing with events. Now, I talked about that 2,000 line of code function that we had to deal with. One of the problems that we faced was there was this big customer and we were trying to improve the SLA for the customer. We were like, hey, there's something in this big giant process that's taking time. We want to make sure that, you know, when these big guys, our biggest customers, drop files, we want to ensure that they get processed within the SLA. We don't want to breach the SLA. So there's obviously something going wrong. There's something that's slowing, or find ways to make it faster, right? You're the Jedis. Go figure it out, right? So one thing that we did was we went in to that big monolith of a function. Every place that was significant that happened, we made that publish an event. And then we added a subscriber on the outside that was listening to all these events come in. So we were able to figure out, like, oh, okay, this process took X amount of time. So we were able to now get complete visibility, which we didn't have before. And it was really cool. With the flow of events, we kind of saw, like, you know, what took time. And we identified this call in that process. There was a call to the billing service trying to price a transaction based on all the features that the customer had asked. And that billing service was taking its time to come back with the right computation based on everything. And then that value was stored in one of the columns, the 200 fields that were in the table. And it turns out that column wasn't being used. So it was an easy fix. Go and comment that call to the billing service to do the calculation. But if we didn't have that visibility, we would never have, like, I mean, we would have eventually found out, but it would have taken us a long while to kind of like nail that problem. So having visibility into your system gives you a whole lot of choices and things that you can make to make your systems go better, right? Now, the other cool thing that you can do with this sort of thing is features on the outside. Now, a lot of times, it's like when that developer wants you, right? This is that 2,000 lines of code. Don't go messing there. Or if you tread there, be very, very, very careful, right? So let's say there's this new feature that business is interested in, and they say that, like, hey, when a customer is preferred, we want to try this brand new promotion that does something else, right? So instead of like writing that code in that big giant monolith, now you've got the flexibility in separating it out. So you can go and identify that piece of legacy code which is responsible, make it an event. So then you can add a little tiny service that's listening to that event, right? It goes into its queue, and then that little service can do whatever it wants. Now, the beauty in this model is you didn't have to write this little tiny service inside that existing code, and the only thing that you did to that legacy code was you made it emit an event. That's not a bad change. It is a change, but it's a small change, a relatively small change. All your core crux of the work, now you've moved it to a different service, which, you know, should be a single responsibility principle type service. It deals with that one thing, right? You can automate it to your heart's extent, add integration tests, unit tests. Maybe some of that is not possible in the existing legacy stuff, right? You've got that flexibility. So, and the cool thing is that data doesn't have to go into that big giant database, right? It can maintain its own persistence, how it wants to store, and even persistence doesn't have to be tied to the same type of persistence. Where a relational database might have made sense before, for this particular task, you could get away with the document database, right? So it even affects, like, you know, the choice of persistence that you might be taking. Now, things like zero downtime deployment become possible because your things are now tiny, right? Now, you have this customer promotions version 1, which is taking messages, doing its thing. Now, of course, business wants something else, and you've got, you know, a small change that you're trying to make. You've got your version 1.1. You don't have to stop the existing service. You could just deploy your new service side by side. And what this means is like both these little tiny services are watching the same queue. So when a message comes in, it can either get picked up by your existing 1.0 service or your 1.1 service. So you kind of like let it flow through and see how your 1.1 is behaving. Monitor your logs, monitor your services, and once you've like, you know, figured out that everything is working okay, you can then go ahead and decommission your, you know, previous version. And now everything will be flowing through your brand new service. Of course, in this model, you have to be careful. You have to be backwards compatible. So you can't be making changes that change table meanings. You can't be replacing fields. So you do have to have that in mind, but that's a good practice in general, to be mindful of, you know, of backwards compatibility. Now, what if things go wrong, right? I mean, it can happen, right? We've been there. So a message comes in, gets processed, blows up, right? When it blows up, that message goes to something error queue, because once you've tried some things like 1,000 times, and if it's failed 1,000 times, it's not going to pass the 1,001st time, right? So there's that configuration of, if it hasn't worked a few times, there's no use trying this message. So let's poison that message and, you know, push it to a different queue, right? So now you know that this new deployment that you just did is broken, but the good news is half your messages are still going to the old version, and those are getting processed. Now you're in the situation where half the messages are now ending up in the error queue, right? So you've done the right thing, which is like you've stopped the new version, the buggy one. Now you've kind of like, you know, stopped the damage. But what do you do with those messages? Now the cool thing is those messages can just be played back to the queue. Once you play it back to the queue, because V1 is watching that queue, it's going to just process that and everything is going to go its merry way. So you can take it down and fix it, redeploy it, and then once it's really working, you know, you can move forward. Now the real cool thing is you can even have like some sort of like A/B testing type scenarios where you try some messages with like, you know, some promotions done one way, some promotions done a different way, so you can have these two different things, you know, customers in North America, maybe promotion A, customers in Europe do promotion B. You can have these things work together. This is possible, right? So what are the gotchas? Now when you're like writing services in this small manner, right, you could have like a lot of these tiny things, right? Watching messages doing its one thing. So you can end up with a bunch of them, right? Now, if you are working in an environment where building and deployment is not automated, this is not going to work for you. I worked in a place where before we deploy, we had to have a document. We had to fill out the steps, and then we had to tell like what was the change and what are the steps, stop this service A. You know, we even had it planned where DBA does this first and then shoots it over to ops installs the service. And of course, as developers, like sometimes we might miss a step, right? Or the ops person's human, right? They executing that step. So either way, mistakes can happen. In which case, rollback's not going to be a fun process to be living with. So, and then you walk into that environment and tell your ops guy, oh, don't worry, I'm going to give you 20 more services like that. That's not going to fly, right? So the first pain there would be to take care of, like, you know, automating the process. So then it doesn't matter whether you deploy 1 or 20 or 100, it's not a big deal, right? Because you're not adding more to the pain, you're actually solving the DevOps pain, in which case they will be your best friends, right? And the other thing is monitoring. Because these things can be running in different areas, like tiny pieces, tiny different queues, so you got to keep track of things. And we said that messages could error out. They could end up in the error queue, but who's watching the error queue? If you're not watching the error queue, you could be missing something important, right? So monitoring becomes a very important aspect. And we said one of the advantages is, like, the joy of working with small services is that it gives you the choice of persistence, right? You're not always stuck to SQL Server. You can use SQL Server for where it makes sense. You can use a document database for where it makes sense. But, like, you know, Spider-Man was told, like, you know, you have great responsibility, right? You have power, but, you know, with it comes responsibility. So does your ops know, does the rest of the team know how to deal with those different persistences? If something goes wrong, are you going to be the one that they're going to be calling on, saying, hey, you know, you're the RavenDB expert, we don't know what's going on, we need to fix this, right? You don't want to get those 2 a.m. calls, right? So when you're introducing a new persistence, it's your responsibility to make sure that the infrastructure and every other aspect, you know, of your company knows, can handle it, you know, are trained, they can take care of it, right? So 3 things, definitely, this is a solved problem. Do not reinvent the wheel, use open source software, and instrumenting with events definitely helps you deal with some pain when dealing with legacy, where you don't have to write brand new code within the existing code base or pushing data more and more into the same database. You can write clean code, like on the outside, using patterns like PubSub. And of course, when you build small autonomous components, you have that flexibility of, like, making changes, deploying it, you know, you have the most flexibility there. Fixing things is not a big deal. If your service is like a few lines of code, fixing anything that broke in there shouldn't be hard. And any changes there are not going to be 7,000 line changes per request, right? It's going to be a that people can keep track of. So so those are the 3 takeaways that I want to share with you today. And finally, if you want to learn more about event-driven architecture, Udi, the founder of NServiceBus, he has an online video course which talks more about temporal coupling, a whole another layer of, like, other coupling and fallacies of distributed and so on. It is a very valuable course, and before I joined particular, I took his course, and it was great, and I learned a lot. So code, and I think you get access to 2 days of videos. Thanks a lot for your time.